This one. Yeah. I want to believe by now you have my screen in front of you. You can unmute yourself to respond. You should see tutorial questions, SMO8, measures of the dispersion, part 2. And on the other side, you should be able to see EDUC 801. Okay? And our major task this evening is to solve as much as possible questions from these 1 to 40 questions. I have 1 to 40 problems based on 2 topics. Since we have 40 questions, I may suggest we start with multiples of 4. So perhaps we can solve 10 questions. If the time permits, we can solve more. Okay? So to get started, let's see the question number 4. Question number 4 here says, in a normal distribution of scores, what percentage of scores lie between z equals to -1, z equals to -1, and then z equals to +1? So what percentage of scores lies between z equals to -1 and z equals to +1? You see, for z-score, which actually is what standard score, z-score, which is actually standard score. I think the last time we mentioned, let me give you the distribution. It looks like this. Okay, of course, this is not perfect. So this is distribution. So the area, let us say this is a midpoint. Okay, this is the midpoint. So z equals to -1 + 1, let us have it. That is -1 standard deviation and then +1 standard deviation. Yeah, +1 standard deviation. Okay. +1 standard deviation. Okay, maybe this is too, the distance is too wide. Let us make it smaller. Let's say this is our -1 and this is a +1. Okay, then we also have -2 standard deviation and then +2 standard deviation. And we also have -3 standard deviation, then +3 standard deviation above the mean. Okay, so the midpoint distribution, the mean is 0 and the standard deviation is 1. Okay, so 1 standard deviation above the mean, this area. Okay, this area under this curve is what they said we should look for. Okay, so in which there is something which we call empirical rule. Let me also demarcate the area for 2 standard deviation with red. So this is 2 standard deviation. It covers everywhere there. Then let me also demarcate that of 3 standard deviation above the mean. 3 standard deviation above the mean. It covers everywhere. So the empirical rule says that, you see, this 1 standard deviation, the 1 standard deviation above the mean, ±1, this area under this particular curve, it is actually 68%. 68%. That means half here is 34%, and then the remaining half is 34%. So this is the first empirical rule. The second empirical rule, that is for 2 standard deviation above the mean. The area that is covered by this enclosure, okay? So this area is actually 95%, okay? Yes. This is 95%. So if this is 95% and this part is 34%. That means the small part you have here is going to be 13.5%, and this small part is also 13.5%. Okay, in such a way that when you add all these numbers together, you are going to get 95. 13.5 plus 34 plus 34 plus 13.5. That will give you 95%. Is that okay? That is a 2 standard deviation above the mean. The last one, which is in our last class, but I said I was not sure whether it was 99.1 or 99.7. So this area that covers from -3 to +3, it is actually 99.7%. Okay, 99. The empirical rule question. The question asks us what percentage of scores lie between -1 and +1. Now we have just said it. -1 and +1, the area that is covered by the normal distribution curve is the area is what? 68%. So the right option there is option B. Okay. So question number 4, the answer is what? The answer is B, 68%. Okay. All right. So I hope this is clear to everybody. So we can go to problem number 8. Yes. Question number 8 says, if the mean score on a test is 50, please pay attention to this. If the mean score on a test has a Z-score of -2, write out what we are given. Score on a test is 50, X bar equals to 15. And the standard deviation S equals to 5. A student now has Z-score of -2. What is the student score? That is, what is X? So what we're going to do here is very simple. We just apply our formula for calculating Z-score and then substitute what we have to get what we don't have. Remember, Z equals to X minus X bar divided by standard deviation. Is it okay? Deviation divided by what? Standard deviation. Deviation from the mean. So our Z is given to be -2. So -2 equals to, we are looking for X, we don't know X, but we know X bar to be 50. Okay, and then standard deviation to be 5. So we just walk through this and get our X. From the simple algebra that we learned before, -2 times 5 equals to X minus 50. -2 times 5 is -10, equals to X minus 50. -10 plus 50 equals to X. 40 equals to X. That means X equals to 40. So the score of the student, okay, is actually what? Is 40. So the right option there is option A. So A. Number 8 is A. I hope this is clear to everybody. If it is not clear, feel free to stop me and seek for clarification. That's why you are in class. And the advantage of being in class. Yes, the advantage of being in class. Thank you. The advantage of being in class is for you to be able to ask questions rather than watching the video later. Let me take the example again. This X bar equals to 50. And the standard deviation is 5. That Z-score of -2. A student has Z-score of what? -2. What is now the score of the student? Find X. What is the score of the student? Okay. So find what? Find x. That is the question. We're looking for x. But you know, according to the formula, that z equals to x minus x bar divided by s. X is the score. X bar is the mean. S is what? Standard deviation. Our z is given to be -2 equals to x minus x bar. X bar is 50 divided by 5, which is standard deviation. Then you just cross multiply or you do your simple algebra. That was why we did algebra review. You are now seeing the importance of that particular lesson. So now you can just multiply. -2 times 5 will give you this one equals to x minus 50. Then -2 times 5 is -10, x minus 50. We have it. Then -10, you collect like terms. You take -50 to cross this border, then it will become +50. So you have -10 plus 50 equals to 40, and that is equals to what? X. So that means x equals to 40. As simple as that. I want to believe this is clear. Thank you. So we can go to the next question, which is question number 12. Question 12 says, which of the following scenarios would likely involve the use of z-squares? Which of the following scenarios would likely involve the use of z-scores? Okay. A, calculating the average test of a class. B, comparing test scores from different tests. C, determining the median score in a data set. D, measuring the range of scores. So tell me, which of these 4 options is correct?
Is B.
The answer is B, comparing test scores from different tests. Any contrary opinion? Any contrary? Okay.
No.
So we go to the next problem. That is problem number. Yes? Somebody has a contrary opinion? No? Okay. Thank you. So problem number 6, z-score change from -1.5 from -1.5 to 0.5 over a semester. What does this change indicate? Please pay attention to this conceptual problem. A student's z-score changed from -1.5 to 0.5 over a semester. What does this change indicate? A, the student performance has declined. B, the student performance has improved. C, the student performance remained the same. D, the student performance is now below the mean. Which one is correct?
B, the student performance has been improved.
B. Thank you. The student performance has improved because it has improved from below the mean to above the mean. Initially, it was 1.5 standard deviation below the mean, but now it is now 0.5 above the mean. Thank you. Thank you. So we now go to the next problem. That is problem number 20. It says, a class has a mean score of 75 with a standard deviation of 8. A student's z-score is -1.5. What is the student's actual score? This is like the question we solved before. That is problem number 8. But now with different numbers. Let us resolve the problem again. A class has a mean, x bar is the mean. That is equals to 75. And the standard deviation, S, equals to 8. A student's z-score is -1.5. Z equals to -1.5. Then what is the student's actual score? What is X? What is X? That is, we want to use our formula for z-score, which is Z equals to X minus X bar divided by standard deviation. Okay? So we will substitute what we have. Z is -1.5. We were given. We don't know X, but we know X bar. to be 75, divided by 8, which is the standard deviation. Equals to x times 8, if I'm not mistaken, and that is equals to x minus 75. Please confirm the calculation. It can be wrong. So this means that minus 12 plus 75 equals to x. This is plus 75 because I'm taking this minus to cross the border, and that border is equality, equals to. So whenever minus crosses the border, it turns to what? Plus. The same thing, whenever plus crosses the border, it turns to what? Minus. So minus 12 plus 75, this gives what? 63 equals to x. That means x equals to what? X equals to 63. Am I correct? X equals to 63. Is there an option? Yeah, the answer is A. The correct option is what? Is A. Is this okay, everybody? Yep. Thank you. So you see, these are the kind of questions, very easy questions that you will encounter in this course. So let's go to the next problem, problem number 24. Okay. Problem 24 says, a Z-score of 1.8 indicate which of the following about a student's score. I read the question again. A Z-score of 1.8 indicates which of the following about a student's score. They want you to interpret. This is a conceptual problem. A, it is 1.5 standard deviation below the mean. B, sorry, 1.8. B, it is 1.8 standard deviation above the mean. C, it is at the mean. D, it is a low performing score. Which one is correct?
Is B, sir.
The right option is option B. Okay, it is 1.8 standard deviation above the mean because it is positive. If it is negative, it will have above the mean because the Z-score is what? Is positive. The next problem is problem number 28. Again, the conceptual problem, less than the median. If the mean is less than the median, which of the following is true about the distribution? If the mean is less than the median, which of the following is true about the distribution? A, it is positively skewed. B, it is negatively skewed. C, it is symmetric. D, it has a large range. Which one is correct?
It is A.
The answer is A. It is positively skewed. Thank you, madam. So if the mean is greater than the median, then the distribution is positively skewed. Whenever mean is greater than what? The median. Okay. Which is greater than mode?
I think it's negative, sir.
Okay.
And it's negative.
It is negative. Okay. Do you remember box plot? Do you remember box plot?
Yes, I remember.
Okay. I want to draw a small box plot now. Okay. This is a box plot of this distribution where the mean is greater than the median. The median is this horizontal line and the mean is above it. Okay. So this distribution now say your answer again. Is this distribution positively skewed or negatively skewed?
It's positive.
It's positive. It's always be positive. If you don't like to use mean greater than the median, look at the whiskers. The upper whisker is longer than the lower whisker. Okay, that is positive
distribution.
skewness. Okay, So take note. Whenever the mean is greater than what is positively skewed.
Sure.
And negatively skewed, the mean will be less than the median, which will be less than the mode. Okay, this is very important. All right. Okay. Okay. All right. So this is fine. Then we go to the next problem, which is problem number 32. Yep. Problem 32. It says, okay, we are going to use this box plot, the figure 1, to answer question number 32. It says, which of the distribution in figure 1 appears most compact? Which of them appear most compact? Okay. I hope you remember compactability, yes? It has interquartile range and quite a number of these things concentrate around that area. So which of the distribution is correct? Distribution A, distribution B, distribution C, distribution D. You go for what?
The most compact is C. C. The most compact is
most
C.
compact is what? Is C.
C,
okay.
Sir. Yes.
C for cat.
Yes, sir.
Okay. Any contrary opinion?
B.
Somebody say B. Somebody say B. Somebody say C for cat. Somebody say B for boy.
B for ball.
I go for C, sir.
Yes, sir.
Any contrary?
Doctor, the A diagram is not showing well.
How come? What about now?
Yes, it's better now.
It is better now. So somebody say.
So I go for C, sir.
You go for C.
Yes, sir.
Okay. So which one is now correct?
See, when you consider the range, it is much more compact than the others, sir. The C.
Did you see this red dot that you have above the whisker?
Yes, sir. We saw it. Does that dot count, sir?
Is this thing? What did they?
Do you see the red dots above the whisker?
Yes, sir.
Yes, sir. We can see it.
What are they?
What are they? Out something. Oh Jesus.
Outlayers.
Outlayer. Yes, outlayer.
Mm-hmm.
No single one is at the bottom. See a lot of them, they are at the top. So it is not compact. We want quite a number of the distribution to be in the box. So we are knocking out C.
Okay.
So we now have A and B left.
B is the answer.
We all agree that
D.
The answer cannot be D. Because D is actually negatively skewed. Okay? It is not compact.
Yes, sir.
So which one is now the answer between A and B?
B.
It should be
B looks
doesn't
promising.
have any outlier.
B. Because the skew are they're almost the same length. And it doesn't have
the same length and it looks compact. It
The
doesn't have outlier. But again, look at the interquartile range. Do you see the interquartile range is wide, is long, right? I mean this rectangle you see here. That is the interquartile range. As compared to the first one, which is
yes,
A,
sir.
the box is small. Okay? Even the outlayers that you see, they are almost equal. If you count, like we have 4 dots at the top. And at the bottom, we also have like 3 or 4 dots, 3 dots.
Yes.
You see? So quite a number of the data sets, they force themselves inside the box. Even though we have outlier from both ends, but large number of the data set, they force themselves inside the box. So that is what we mean by compactibility. It is compact. The answer would have been C initially, which is a bit smaller than A, the box. However, all the out layers, they are only in one direction. It is skewed, and in fact, it is all, but the answer here is A, because it is the one that represents, because it is compact does not mean it cannot have out layer. Okay, but the distribution of the out layer is what we are interested in. So the distribution here, it shows uniform distribution. And in fact, can you see that? Because look, the mean is equal to the median in the first distribution. Do you see that? A is on the line inside the box. That means the mean is equal to the median. And the length of the whiskers, they are equal. Okay, so that shows that this is normally distributed. So the correct option there is option A. Take note.
Please,
Okay.
I have a question, sir.
Please go ahead.
That of A is having 3 dots, meaning it's having 3 out layers.
Yes.
But the under is having 2 dots. Then I don't know where the interquartile range line is.
Okay, the interquartile range is just you see this box? You see the box, man?
Yes, sir.
Do you see the box?
Yes, sir.
Okay, this box, the beginning of the box and the end of the box. If I can measure very well, maybe this will be like minus 0.8, the bottom, minus 0.8. And the top is going to be maybe 0.8. Okay?
Yes,
so
sir.
IQR is going to be 0.8, okay? The length of the box. Plus, minus, then what? Because this is minus again. So minus and minus will give you plus. 0. What? Remember our IQR is Q3 minus 1.
Minus Q1.
Okay? Is Q3 minus Q1. So Q3 is the upper part. That is 0.8. And Q1 is the lower part, minus 0.8. Okay? So IQR is going to be Q3 minus 0.8. So this is 0.8 plus what? 0.8. And this gives what? 1.6. So the interquartile range, 6. Okay? Remember interquartile range. It means percent of this data set range. But when you consider the second out, for B, for distribution B, the lower box, the lower end of the box is very close to minus 2. Maybe this will be like close to minus 1.8. But when you look at the upper box, that one too is also closer to what? To 2, to positive 2. Let's say Q3 is 1.8. So IQR will give me what? Q3 minus Q1. And this is 1.8 minus 1.8. So this is 1.8 plus what? 1.8. And this is what? 3.6. So IQR equals to what? 3.6. So that means 50% of the data set in distribution B falls between the range 3.6. Can you see that now?
Yes, sir.
So which is larger, the space is larger as compared to 1.6. So this is where compactness comes in. So A is more compact than B because 50% of data set in A, they fall only within the range of 1.6. Why that of B, they fall between the range of 3.6. But look at that C. C is even smaller than A. But unfortunately, the problem with C is the fact that it is positively skewed with a lot of data set outside of the box. Okay? And when you even look at D, you can see that one is even is much. By the time you measure the length, now you will see the length is bigger than 3.6 even. Okay?
Yes,
Let
sir.
us calculate that of D. For distribution D, Q1, that is the lower end, that is -2. And Q3, that is upper end, that is +2. Okay? So IQR equals to Q3 minus Q1. So this is equals to 2 minus -2, which is equal to 2 plus 2. And this is equals to what? 4. So IQR is equals to 4. You can see this is bigger. So the most compact distribution is actually the first one. Thank you very much. Yeah, we are not in box. If a box plot shows, what does it say about the distribution? A, it has a low range. B, it has high variability. C, it is positively skewed. D, it is negatively skewed. Tell me the answer. What is the answer?
It has a high variability, B.
Yes, sir.
It has a high variability. I think that is correct.
Yes, sir.
Nobody should argue this, yes? Or any contrary opinion? If the interquartile range is big, that means there are, I think we even treated this in class, regardless of box plot. When we are talking about interquartile, we say the bigger the interquartile range, the higher the variability, right? Thank you. So the interquartile range tells us about how spread your data is. So let's go to the last problem. That is problem number 40. Okay. Problem number 40 says, if the whiskers in a box plot extend far beyond the box, what does this indicate about the distribution? A, high central tendency. B, low variability. C, high variability. D, symmetric. If the whisker in the box extend far beyond the box.
Is this
Is what?
Is this D?
D, symmetric.
B.
B for boy, low variability.
Yes, B.
Okay.
Is the answer is
Any
this
contrary opinion? Somebody say B.
Is C.
Is B for boy?
Excuse me,
Somebody say
sir.
C.
In that question, why would they not indicate
Yes.
if it's the right whisker or the left whisker that extend beyond the box?
No, they say the whiskers. That means the two of them.
Okay. Okay.
Yeah. So the two whiskers.
The answer is C.
The answer is C.
Symmetric.
Okay. So somebody
Symmetric
say the
D.
answer is. You want to pick D, symmetric?
Yes, sir.
D for dog. Okay. Now maybe we need to vote now. Or let us do elimination. Let us start with the last one. Let us eliminate the last one immediately. You see, for D, a distribution is symmetric if the mean is equals to the median. If the mean equals to the median, then the distribution is what?
Symmetric.
Is symmetric. If the mean equals to what? A box plot. With long whiskers.
You see, high variability.
Okay, so that is to the median. In fact, either the upper one is longer than the lower one, or the lower one is longer than the upper one. It's difficult for it to be equal. So D cannot be low variability. I think before we talk about low variability, what is the implication of this long whisker?
Yes.
The implication of this long whisker is that you are going to get what? High what? Range. You get high range, because range is maximum minus what?
Minimum.
The max is the upper part here, and the mean is the what? The lower part. So the longer the whiskers, the bigger the what? The range.
The range.
And when range is high, what does that tell you about the variability? What does that tell you about the spread in your data set? If the range is high in a data set, what is the interpretation? I want you to give me the answer like this. This one now, you should be saying it without any hesitation.
Have a low variability.
If the range is high, okay? If the range is high, what does that tell you about the spread of your data set?
Low variability.
High variability.
Low or high?
It's supposed to be high, sir.
It's supposed to be high, man. So
Yes,
because
sir.
you have this data set, see, 1, 2, 5, 10, 150, 250, or 201. What is the range? The range is 201 minus 1, which is what? 200. The range is high. It's telling you that the data set that you have inside too, they will have high variability. As you can see, from 2 it jumps to 10. From 10 it jumps to 150. You see it now? So when the range is going to be high, we started this example in our class with a pre-test and post-test or something like that. So take note. So when the range is high, there is high range, which will lead to high variability in your data set. I hope this is clear.
Yes.
Yeah. So these conceptual problems, they are the one that I'm after. I'm after the interpretation. The calculations for me, they are immaterial, because computers can do this calculation far better than you, even far better than me. Okay? But what about the interpretation of what you see? How can you take this to your research? That is our major concern in this course. So these small interpretations, they are very vital. Take note of them. Is it okay, everybody?
Yes, sir.
Yeah. I think we have a good plan. Maybe we can stop here for today.
So what's the answer, sir? Number 40.
The right answer is C.
The answer is C
right?
now.
D.
High variability.
C.
C, madam.
C, D.
for car.
D. Okay. Okay. High variability.
Question
C.
number 40. The right option is C. C for
Doctor,
car.
we are very grateful.
So thank you very much. So
Thank you, sir.
yeah, I think